Dear students, in this video, we'll do some few more dimensions in +1 level. And then we'll do some application of some problems. Its application, some problems. So now, coefficient of viscosity eta. What is coefficient of viscosity? It is a fluid friction experienced by us. Eta, it's called eta, okay? Eta is equal to stress by strain rate, the easiest way. Strain rate. In NCERT, easiest way. It is NCERT not only. NCERT. Strain, what is strain? Strain is, that is, strain rate is, don't by heart it, strain by time. By time. So strain dimension is, last video we saw, is equal to L raised to 0 by T. T minus 1, dimension of frequency, remember it. Stress is, so eta is equal to M force by area by, this is a force by area by 1 by T. So what will get you? Force by area into time. Force by area into time. So dimension will be M L T minus 2 divided by L square into T. So its dimension will be M L minus 1 T minus 1. Dimension is eta. Remember it. Dimension eta is equal to M minus 1 T minus 1. Next I'm going to teach you, introduce you angular momentum. Angular momentum. Angular momentum. Angular momentum. Represented by L. L is equal to M into V into R. So what is L? L is angular momentum. L dimension is M into L T minus 1 to L. M L square T minus 1. Okay. Very important dimension. M L square T minus 1. This is M into M into L T minus 1 into L. That is M L square T minus 1. M L square T minus 1. This angular momentum, right? This is important dimensions. You have some special question on it. Next one is time period. Time period is time only. Time period is time only. Time period. Eta, it is called coefficient of viscosity. Coefficient of viscosity. Now time period is time only. Next one is frequency. What is frequency? How many times you eat food? That is frequency. Frequency is equal to 1 by time. T minus 1. Frequency is equal to 1 by time T minus 1. Now, next is Planck's constant. Planck's constant. Planck's constant. Planck's constant. What is Planck's constant? Is Planck's constant. PLANK, Planck. Delta by Planck's constant. H. You have the formula E is H in nu. It's the energy of particles like electron, photon, and all. So nu is frequency. So H is equal to E by nu. There's no point of teaching you won't understand anything here now. E by nu is, nu dimension is 1 by T. So E is energy, E is equal to energy. Energy is work done. So energy, for dimension, energy is mad only. Right? So what will you get is H is equal to M into A into D divided by 1 by T. So M L square T minus 2 into T. That you get it as M L square T. Earlier we had done what you call Planck's constant. So you have important point note here. Planck's constant and Planck's constant and angular momentum have same dimension. Next is velocity gradient. So many portions are there. Velocity gradient is that we'll learn next. Now we'll do some problems. First question is question 1, number 1. Name the physical quantity. Name the physical quantity whose dimensions are as follows. Whose dimensional formula are as follows. First is 1 ml square T ml square T. This is familiar dimension, you can do it directly. It's work or energy. Then you solve its solution. We will solve it like this. So how will you solve it? You break up dimension, what you know, force you know, write that solution. M L T minus 2 into L. MLT T minus 2 into L. That is this force into distance. This is dimension force. L is distance. It can be what is called? It can be work, energy, torque, etc. Normally we write work. Second question. ML square T minus 3. This also take with the respective force. Always reference is M force reference. Reference one is force. Okay. One reference dimensions you can take force. When you solve this kind of problem, either take dimensions, reference dimension is force, velocity, acceleration. From here you can calculate maximum of dimensions. In this case, so MLT minus 3 is equal to, MLT minus, MLT minus 2, what is it? Then L into T minus 1. So, one way of doing it. If you are not getting it, let's do a different way. You already know what is it? ML square T minus 2 is, if you know this one, L T minus 2 is force dimension. Then one L is there. Then T minus 1 is there. Very dangerous. Velocity. Velocity only, no problem. So you have this is M L T minus 2 L by T. So this is force into L distance. One way of seeing it by time. It's nothing but force, it's work done. Work done by time. This is method 1. So power. Another one, work done has got another formula. Another power is got another power is equal to F into V. Or another form F into V. Those who know they can do it. Method 1 it is. Method 2 is this method 1. Method 2. What is power is equal to force into velocity. Force into velocity. So what is power here? Power is equal to, what is it? This is force. This part is force. This is the given formula. Sorry. Write better way. That is M L T minus 2 into L T minus 1. So those who know this formula, okay, you will be learning afterwards. F into V. F into V is power. Okay. Dimension of power. Next quantity, I hope you followed it. Third one. Next quantity will write. Third quantity is MT minus 2. What do you do it here? MT minus 2. Can you just think for a few seconds? Same. We write force term. Try to bring force. Try to bring force. That is can be written as M L square T minus 2 by M L T minus 2 by 10. M L T minus 2 M L T minus 2. That is nothing but this is force M into A by length. Force by length. Force by length is surface tension. Is surface tension or spring constant. Both are correct. Or spring constant. Spring constant. Okay. Next we will do. Hope you followed it. ML minus 1, fourth one is M L minus 1 T minus 2. So how do you write it? How would I write? Is equal to, let me see, M L square T minus this force we know. It should be L square here. That is, this is force by area. See, and minus 1 should come. So the force is ML T minus 2 by L square. Dimension formula. Force by area. It can be what are the answer can be? Answer can be pressure or stress or elastic constant. Elastic constant or constants or modulus, whatever may be.